Alright, so 4.4 is the unit circle. So now we're ready to explore trig functions. We'll use the unit circle approach. Unit circle that we will develop is the most useful tool in trigonometry. It provides an easy way to recall trig values of the most popular angles. To be successful in this class and then later in calculus and beyond, you must understand it, and beyond this class you must memorize it. Alright, so first it talks about a geometry connection. So it says, let's remember the important ratio relationships for two famous triangles. So remember the 30, 60, 90, we talked about this the other day, and we had said that its sides were in the proportion of, or the ratio of, of x, x squared root of 3, and 2x. Well, the other day we said we were going to let x be 1, and we were able to find our triangle from there. But here it said, let's name the lengths of the sides if the hypotenuse is 1. So we're going to let our hypotenuse here be 1. Well, remember, and then across from the 30 is x, but the hypotenuse, is 2x. So that means that 2x is equal to 1. So we can solve for x. And so we know x is just 1/2. And so across from the 30 degrees, we know the side was just x, so that's just going to be 1/2. And across from the 60 degrees, we knew our side was x squared root of 3. So we would get 1/2 square root times the square root of 3. Which really gives us then the square root of 3 over 2. And then the same thing with the 45, 45, 90 triangle. We had said that its sides were in the ratio of x, x, and x square root of 2. And so the same idea here. It says we're going to let the hypotenuse be 1. So if my hypotenuse is 1, then that means that x square root of 2 is equal to 1. So we could divide by the square root of 2. And we find that x is equal to 1 over square root of 2. But remember, we can't have a radical on bottom. So we multiply the top and bottom by it to rationalize it. And we end up with the fact that x is equal to the square root of 2 over 2. Well, across from both of the 45-degree angles, our side is x. So we know that this is the square root of 2 over 2. And this side over here is also the square root of 2 over 2. And then we look at the unit circle. So it says the unit circle is a circle of radius 1 centered at the origin. So if we think back to what we know about a circle, we know a circle has the general form of x minus h squared plus y minus k squared equals r squared, where our center is h comma k. Well, if my center is at the origin, that's at 0, 0, which means my h is 0 and my k is 0. So we know then, with our unit circle, that x squared plus y squared has to equal r squared. Now, particularly for those that are on the unit circle, remember the unit circle means our radius is 1, and so therefore we know that x squared plus y squared equals 1 squared. And so we can say that it's x squared plus y squared equals, and 1 squared is just 1. Now we will actually use this one here a lot, okay, because not all the time is our radius going to equal 1 of some of the information that they give us. But if it's on the unit circle, we know that x squared plus y squared has to equal 1. Alright, and so it says the trig functions of any angle, so let theta be an angle in center position with x, y as a point on the terminal side of theta. And then we can find the radius by taking the square root of x squared plus y squared. Well, guys, it just comes from the fact that x squared plus y squared equals 1. Okay? Just comes from that, r squared. And so that's why I said before we would use that quite a bit. Now they took and solved for r, but we're not always after r. Sometimes they tell us r and we're after x. Or they tell us we're after y. So we're not always after r, so I typically don't use it where it's solved for it, but I will use this for all three of them when something's missing. Okay, so example 1 says use the figure at the right to name the 6 basic trig functions in terms of x, y, and r, where r is going to be the radius of our circle. Now it may not necessarily be the unit circle though, okay? So remember SOHCAHTOA there where we talked about sine. We talked about the 6 trig functions in terms of opposite, adjacent, and hypotenuse. Well, we're going to do the same thing here. So remember though, but we're going to change it using what we know on this triangle. So let's look at the triangle. we look at the triangle, we can see here though that on the circle, the ordered pair there for our angle is x comma y, which means the x value is how far it went to the left, or right, excuse me, and the y value is how far it went up. It's kind of like the axis, guys. The x values are horizontal and the y value is the vertical. Alright, so, and then the radius, of course, it would be across from that 90 that the triangle would, that would form that triangle there. Alright, so remember the sine was opposite over hypotenuse. Well, in this case, when I look at that triangle, my opposite is y and my hypotenuse is r. So I can say the sine is y over r. That means its reciprocal cosecant is going to be r over y. Cosine was adjacent over hypotenuse. So if I look at that triangle, now I'm looking at, let me specify, my angle theta is right here, okay? So if I'm looking for the adjacent, that's x over the hypotenuse, which is r. The reciprocal of cosine is secant, so secant is going to be r over x. Now remember, tangent was opposite over adjacent. And so therefore, when I look at this triangle, my opposite is y, my adjacent is x, so tangent is going to be y over x. And so its reciprocal cotangent would just be x over y. And so we're going to kind of move away from using opposite, adjacent, and hypotenuse, and we're going to move into more using our x, y, and r. So x is going to be our horizontal, y is going to be the vertical, and r is always going to be the radius, okay? So looking at where the trig functions are positive. So this is looking at where what x and y are in each of the quadrants. So let's look at quadrant 1. In quadrant 1, remember that, let me draw the quadrant here. Alright, so in quadrant 1, remember that x is going to be positive, y is positive, and r stands for radius. Radius is a distance, so radius is always positive. So when we look at sine of our angle, we know that sine is y over r, and in quadrant 1, y is positive, r is positive, which means sine is going to be positive. So sine and its reciprocal cosecant are positive in quadrant 1. Cosine is going to be x over r. In quadrant 1, x is positive, r is positive, positive over positive is positive. So in quadrant 1, cosine and its reciprocal secant are also positive. And then tangent. So tangent of theta, remember, is y over x. In quadrant 1, y is positive, x is positive, and so tangent is also positive in quadrant 1 along with its reciprocal cotangent. Those are plus signs for positive, by the way, guys. Alright, quadrant 2. In quadrant 2, remember, we know that x is now negative, y is positive, and r is always positive. So when we do sine, sine remembers that y over r, so we got a positive over a positive, so sine is positive along with its reciprocal cosecant. Cosine remembers x over r. In quadrant 2 here, x is negative, r is positive, and negative divided by positive is negative. So cosine and its reciprocal secant are both going to be negative in quadrant 2. And then tangent, remember, is y over x. Y is positive, x is negative, positive divided by negative is negative. So tangent and cotangent are both negative in quadrant 2 as well. Then in quadrant 3, remember that x is negative, y is also negative, but r is always positive. So sine remembers y over r, y is negative, r is positive, so sine is negative. So sine and its reciprocal cosecant are negative in quadrant 3. Cosine is x over r, x is negative, r is positive, negative divided by positive is negative. So cosine and its reciprocal secant are both also negative in quadrant 3. Tangent remembers y over x, y is negative, x is negative, and negative over negative, though, is a positive. Therefore, tangent and cotangent are both going to be positive in quadrant 3. And then quadrant 4. Quadrant 4, remember that x is positive, y is negative, and r is always positive. So sine is y over r, so it's going to be a negative over a positive, which gives us a negative. So sine and cosecant are both negative in quadrant 4. Cosine is x over r, x is positive, r is positive, so cosine and secant are both going to be positive in quadrant 4. And then tangent, remember, is y over x. Y is negative, but x is positive. Negative over positive is negative. So tangent and cotangent are both negative in quadrant 4. So a good way to notice is just worry about where are they positive. Because if you know where they're positive, then you know if they're not positive in that quadrant, they have to be negative, okay? So I use all students take calculus. Now I know it may not be true, but that's what helps me remember which ones are positive. In quadrant 1, they're all positive. Alright, so sorry about that. If there was a blank spot there, I had to get up and grab the charger. Thought I paused it, but it didn't look like I did. Alright, and there's our unit circle. So now guys, if you watch the other videos that I posted here, it tells you how to build your unit circle, okay? So that'll help you get that built. As far as the ordered pairs, I can't recall right offhand if it helps you or not, but let me go back over how to do that then. Okay, so remember we talked about those triangles before. And so we looked at, like, let's say the 45, 45, 91. Well, actually, before we do that, let's look at the quadrantal angles. So let me make my screen a little smaller here so everything fits here. Okay. Now, so for my quadrantal angles, remember this is a unit circle. And so we know that the radius from the center to the edge right here is 1 unit. So if I'm going to the right, that ordered pair would be 1, 0. If I'm going up, the ordered pair up here would be 0, 1. If instead I went to the left, the ordered pair right there would be negative 1, 0. Or if instead I went down, the ordered pair down here is negative 1, 0. Okay? Now, let's look at that 45, 45, 90 triangle. And so we had said it was x square root of 2 before, and we had said, well, if we let x equal 1, no, it doesn't matter. We can use a 1 from the beginning. Actually, let's just do that. So at the beginning of the notes, we had that 45, 45, 90 triangle. All right? And so we had said that that was a square root of 2 over 2, square root of 2 over 2, and 1. Now remember, we had said like sine of theta is y over r. And on our unit circle, r is 1, so sine is just the y value. So for 45 degrees, my y value is a square root of 2 over 2. Now cosine, remember we said is x over r. On the unit circle, r is 1. So it's x over 1, which is just x. Which means cosine of our angle is equal to the x value of its ordered pair, which is, in this case, the x is the square root of 2 over 2. So we know at 45 degrees right here that it's going to have the ordered pair of the square root of 2 over 2, square root of 2 over 2. Now remember, everything in the unit circle is a reflection of that first quadrant. So if I take this point here and I reflect it into the second quadrant, it's right there. We just talked about x and y in all 4 quadrants. So we know in quadrant 2 that x is negative. So I'm going to use the same ordered pair, but I'm going to make the x value negative. In quadrant 3, if I reflect that over, it's right here. And we had said x and y are both negative. So they're both going to be negative numbers. And then when we reflect it over into quadrant 4, we said x is positive, but y is negative. So that's what we're going to do as well. Now, for the 30, 60, 90, we had this triangle earlier. Now, it depends on which one. They started out, I believe, with 60 degrees here, okay? And so the 30 degrees was here. Now, remember, this is the angle that's in standard position. So we're first looking at it at the 60 degrees. So, and we'd said our sides were 1/2. It was a square root of 3 over 2, and it was 1. Same idea, because sine is y over r. R is 1. So sine is going to be the y value. Well, if I look at the y value here, it's going to be the square root of 3 over 2. Cosine is x over r. R is 1, which means cosine is x. And our x value right here is 1/2. So we come out with the ordered pair for 60 degrees to be 1/2, comma, the square root of 3 over 2. So at 30 degrees right here, I'm going to put 1/2 and the square root of 3 over 2. Now notice, it's the one that's closest to the x-axis, right? So when we reflect, it's going to be the one that's closest to the x-axis. So when we reflect into quadrant 2, it's over here. We know x is going to be negative, y is positive. Reflect into quadrant 3, x and y are both negative. Reflect into quadrant 4, x is positive, but y is negative. And it's the same idea when we look at it with the 30 degrees now being in, I wrote that on the wrong one. That was 60 degrees, and I wrote it on all the 30s. I am so sorry. I would start the video over, but I'm too far into it now. Alright, I'm so sorry. So that was for all the 60 degrees, which is the one here, which let me specify. This is the one that's closest to the y-axis. So when it reflects, it's always going to be the point closest to the y-axis. So it was 1/2 square root of 3 over 2. So this would have been negative 1/2 square root of 3 over 2. In the third quadrant, they're both negative. And in the fourth quadrant, only the y is negative. So sorry about that, guys. Alright, so back to this one. Now let's put 30 degrees in standard position, which means the 1/2 is over here, the square root of 3 over 2 is now here, and the r value is still 1. Okay, so it's the same idea, but we notice this time, in place of the y is 1/2, and in place of the x is the square root of 3 over 2. So my ordered pair is going to be the square root of 3 over 2, comma 1/2. The x and y just switched because, well, my angle switched places, so did the sides. So now here at the real 30 degrees, we're going to get the square root of 3 over 2, 1/2, and then we're just going to do our reflections again. So quadrant 2, x is negative. Quadrant 3, they're both negative. And in quadrant 4, only the y value is negative. Alright, and that's how we got those ordered pairs. So it tells me to find the exact value of the trig functions. So I'm actually going to jump down here. Actually, I'm going to do the quadrantal ones first because they're just a little bit easier typically. And then we'll go up and do the other ones, okay? So let's see. First, we're going to start out with 0 degrees or 0 radians, whichever way you want to look at it. We know it has an ordered pair. If you look at 0 degrees, 0 radians on your unit circle, we wrote the ordered pair 1, 0. And remember, because it's on my unit circle, my radius is 1. We'll also remember, before I get going on that one, that sine is our y over r, cosine is x over r, and tangent is y over x. Cosecant, the reciprocal of sine. Secant, the reciprocal of cosine. And cotangent is a reciprocal of tangent. And so we're just going to plug in our x, y, and r excuse me, and simplify it for each of them. So, for sine of 0 degrees or sine of 0 radians, Now remember, your ordered pair has an x and a y in it, and we already know our r is going to be 1. So when I do y over r, I get 0 over 1, which is 0. Now if you want to, you can go ahead and do its reciprocal cosecant. Now, so if I flip that over, that would be 1 over 0. You can't divide by 0, so it's undefined. So the reciprocal of 0 will be undefined, which means the reciprocal of undefined is going to be 0. Alright, for cosine, we said it's going to be x over r. Our x value is 1, our r value is 1, so we get 1. So its reciprocal secant, if I take the reciprocal of 1, it's just going to be 1. And then tangent is y over x. My y is 0, my x is 1, 0 over 1 is 0. And so for its reciprocal cotangent, I know the reciprocal of 0 is now undefined. Alright, we're going to do the same thing here for 90 degrees. 90 degrees has an ordered pair of 0, 1. It's on my unit circle, so the r is 1. So I'm going to do sine is y over r. 1 over 1 is 1. Its reciprocal cosecant, the reciprocal of 1 is still 1. Cosine is x over r, so we get 0 over 1, which is 0. Its reciprocal secant, the reciprocal of 0 is undefined. Tangent is y over x, so it's 1 over 0. Can't divide by 0, so that's undefined. Therefore, its reciprocal cotangent, the reciprocal of undefined, is 0. Alright, let's keep going. So 180 degrees, or pi, has the ordered pair negative 1, 0. For its x and y, we know r is 1. So sine is y over r. 0 over 1 is 1. Its reciprocal cosecant is also going to be 1 then. The reciprocal of 1 is 1. Cosine is x over r. So 0 over 1 is 0. Its reciprocal is secant. So secant, the reciprocal of 0 is undefined. And then tangent. Tangent is y over x. So 0 over negative 1, which is 0. The reciprocal of 0 again is undefined. And then last here is the 270 degrees. 270 degrees has an ordered pair of 0, negative 1. It's on our unit circle, so we know r is 1. So sine is y over x, y over r, so negative 1 over 1, which is negative 1. Its reciprocal cosecant, the reciprocal of negative 1, is still negative 1. The sign doesn't change on a reciprocal, it just flips the fraction, remember? Cosine is x over r. X is 0, over r is 1, which is 0. Its reciprocal secant, then, is going to be undefined. Tangent is y over x, so we got negative 1 over 0. Can't have 0 on bottom, so it's undefined. So its reciprocal tangent, or cotangent, is going to be 0. Alright, and so you don't have to memorize these because they're going to be on your unit circle, and it's easy to build if you had to. So now that we did that, let's go back up here to 30, 45, and 60 degrees. So we're going to do the same thing. 30 degrees, 45 degrees, and 60 degrees all have an ordered pair. They're all on my unit circle, so I know their r value is going to be 1 for each one of them. And then we're going to go through and we're going to find those 6 trig functions. So for 30 degrees, remember it has an ordered pair, the square root of 3 over 2, 1/2. So that's my x and my y. We know our r is going to be 1. Well, sine, remember, is y over r. So my y is 1/2 over 1, which is 1/2. Cosine, remember, is x over r. X is the square root of 3 over 2 over 1. So we get the square root of 3 over 2. Now tangent's where it gets a little more fun. Tangent is y over x. And so if I take y, which is 1/2, and I divide it by x, which is the square root of 3 over 2, I'm going to write this outside this box so I can write it a little bigger. So I'm going to go over here on the right side. So if I take 1/2 and I divide it by the square root of 3 over 2, we don't like fractions within fractions, so let's multiply by 2 to get rid of that little denominator there. And what you do to the top, you have to do to the bottom. Well, how nice. It made it go away, correct? So we get 1 over the square root of 3. You can't have that radical on bottom, so you're going to have to get rid of it. So we end up with the square root of 3 over 3. Now, the reciprocal of sine is cosecant, so we can either do r over y, or we can just do the reciprocal of sine. So we get, either way, we get 2 over 1, which is 2. Now, secant gets a little trickier. Secant is a reciprocal of cosine, so it's r over x. But if I look at cosine, it's 2 over the square root of 3. Well, we can still do that because it's still 2 over the square root of 3. We can't have that radical on bottom, so we're going to multiply top and bottom by the square root of 3. And so we end up with 2 square root of 3 on top over just the 3 on bottom. And then cotangent is a reciprocal of tangent, so we can do the same thing. It's x over y, or we can say it's 3 over the square root of 3. Multiply by the square root of 3 to get it off the bottom. So we end up with 3 square roots of 3 over 3. These 3's will cancel, so we just end up with the square root of 3. All right, 45 degrees. It has an ordered pair of the square root of 2 over 2, comma, square root of 2 over 2. It's on my unit circle, so I know r is 1. So sine, which is y over r, is going to be the square root of 2 over 2 over 1, which is the square root of 2 over 2. Cosine, x over r, so we get the square root of 2 over 1. Again, square root of 2 over 2. Tangent is y, the square root of 2 over 2, over x, the square root of 2 over 2. Guys, this is something over itself. So remember, they cancel, and we just get 1. Now, cosecant is a reciprocal of sine. So I'm just going to say it's 2 over the square root of 2. Get the radical off the bottom. So we have 2 square root of 2 over 2. Those 2's will cancel, and so we get the square root of 2. Secant is a reciprocal of cosine. So, but wait, if sine and cosine were the same, then secant and cosecant are also the same. So automatically know that this is just going to be the square root of 2. And then cotangent is a reciprocal of tangent. Well, tangent was 1, and the reciprocal of 1 is 1. And then 60 degrees has an ordered pair of 1/2 square root of 3 over 2. So when I take sine of 60 degrees, that's y over r. So it's going to be the square root of 3 over 2 over 1, which is the square root of 3 over 2. Cosine is x over r, so 1/2 over 1, which is just 1/2. And then tangent is y over x. So I'm going to come over to the side again here and do this one. So y over x, my y is the square root of 3 over 2. My x is 1/2. So I'm going to do the same thing. I'm going to multiply by 2 to get rid of the little fractions. And so we get the square root of 3 over 1, which is just the square root of 3. Now these numbers look familiar. That's because we saw them up in the 30-degree column. Because 30 and 60 come from the same triangle, just remember x and y are switched, which means sine and cosine are switched. And secant and cosecant will be switched, okay? So we don't actually have to do a whole lot of work here. When we go to do cosecant, we know cosecant's a reciprocal of sine, so it's a reciprocal of 3/2. But I look up here where cosine was square root, I said 3/2, square root of 3 over 2. Cosine, we found the reciprocal to be 2 square root of 3 over 3. So we know the reciprocal of the square root of 3 over 2 is 2 square root of 3 over 3. Then the reciprocal of 1/2, of course, is just 2. And then the same thing here. The square root of 3 is what we had gotten originally for cotangent at the 30-degree one. And so its reciprocal is what we had for tangent, so we know it's going to be the square root of 3 over 3. You can definitely work them out to get the same answer, but I'm just using what I've already worked out to find those answers. Okay, so I can find sine, cosine, tangent. I can find all 6 trig functions of any of those angles that we put on our unit circle. All right, and then the last part here is even and odd functions, okay? So we talked about even and odd functions back when we talked about regular algebraic equations. So it says, remember that a function f is even if f of negative x is equal to f of positive x for all x in the domain of f. So this is where we had plugged in negative x, we simplified the algebraic equation or expression, and we said if it was the same, it was even, okay? Because if I plug in negative x or positive x, I'm going to get the same answer. And then we had said a function f is odd if f of negative x is equal to negative f of x for all x in the domain of f. That was where we plugged in negative x. We got the same digits, but all of our signs changed. So all the positives became negatives, all the negatives became positives. That was how we knew it was odd. All right, so for trig functions, I'm telling you, even functions are going to be cosine and its reciprocal only. Cosine and its reciprocal only. That means if I plug in a negative angle and I plug in the positive angle and I'm taking the cosine or secant of both of them, I'm going to get the same exact answer. Okay? All of the other trig functions are going to be odd. So you don't have to remember which ones are even and odd. Just know even is cosine and its reciprocal. Everything else is odd. Which means if I plug in an angle, whether it's positive or negative, I'm going to get the same digit, but a different sign if I plugged in like the negative of it. All right, so, and we got some examples here to help us. So let's look at example 4. So example 4 says to find the exact value of the following. So tell me, is cosine even or odd? Well, cosine is even. What that means is it doesn't matter if I have a negative 60 degrees or a positive 60 degrees here, I'm going to get the same answer. So this is the same as if I had cosine of positive 60 degrees. Now, why would I want to use positive 60 degrees instead of negative 60 degrees? Positive 60 degrees is on my unit circle, and I can find its ordered pair. I know that 60 degrees has an ordered pair of 1/2 square root of 3 over 2. Look at your circle. Okay, I also know it's on my unit circle, so r is 1. Now, I know that cosine itself tells me it's x over r. So I'm going to look at my ordered pairs. I got my x, which is 1/2, over my r, which is 1, which tells me that cosine of 60 degrees, which is the same thing as cosine of negative 60 degrees, is 1/2. Now, we could have used coterminal angles just as well to find this, okay? This one just took less doing because when I took the opposite of the negative 60, the positive 60, it was already on my unit circle. But I could have definitely taken negative 60 degrees, added a full circle, so it would be the same as the same ending terminal side is 300 degrees. And if I'd have found cosine of 300 degrees, I'd have still got 1/2. All right, so sine of negative pi over 2. So tell me, is sine even or odd? Sine is odd. So what that means is I'm going to get the same digit answer as if I did sine of pi over 2, but the SIGN is going to be different. So if sine of pi over 2 is positive, my answer for sine of negative pi over 2 is going to be negative, or vice versa. If sine of pi over 2 is negative, then sine of negative pi over 2 would be positive. So we have to put the negative symbol out in front. All right, well, pi over 2 is on my unit circle. It has an ordered pair of 0, 1, and it's on my unit circle, so I know my r is 1. So I'm going to keep my negative sign as part of my answer. Sine, remember, tells us that we're going to use the y over r. So I've still got my negative. My y is 1. My r is 1. So I get negative, and 1 over 1 is 1. So negative 1 is our answer. Now, tangent of negative pi. Well, tangent, is it even or odd? Tangent is odd. Therefore, we know it's going to have the opposite sign as the tangent of positive pi. Pi is on my unit circle. It has the ordered pair of negative 1, 0. We know our r is 1. So I'm going to keep my negative. Tangent tells me we're going to look at y over x. So we got negative. Our y value is 0 over our x value, which is negative 1. So we could say it's a negative, and then 0 over 1 is 0, but we don't have a negative 0, so we just say it's equal to 0. Now on 4D, it doesn't really matter if we use the negative 11 pi over 2 or the positive 11 pi over 2. It's not on my unit circle either way, okay? So either we can add or we can subtract coterminal angles, and we'll end up in the same location. So I'm going to go ahead, though, and start it out like we were doing. Cotangent is odd, so I know it's going to be equal to the opposite sign of whatever cotangent of 11 pi over 2 is. Because we deal better with positive numbers, so that's why I took it to the positive here. Now, for that angle, we said it's 11 pi over 2, and so I'm going to change that into a fraction. 11 divided by 2 is 5.5 pi then. So I'm going to, that's too big. Remember, I need it to be between 0 and 2 pi. So I'm going to subtract out a full circle. So 5.5 minus 2 is 3.5, and I still have my pi. Still too big. Subtract out another full circle. That tells me, is that 1.5 pi? That is on my unit circle. 1.5 is 3/2, so this is in the location of 3 pi over 2, which means it's going to be negative the cotangent of the 3 pi over 2. It's equal to that as well, okay? So 3 pi over 2 has an ordered pair of 0, negative 1. It's on my unit circle, so r is 1. So we're going to have the negative. Remember, cotangent is x over y. So we get negative. Our x value is 0. Our y value is negative 1. And we end up with 0 still as our answer. All right, so that's 4.4, guys.